mean, thank you. Both were very great and stimulating presentations. And I think we see more and more that, you know, we can develop better models. And I think we want to try and see how much relevant they are to test new drugs. So starting from you, Laura, you presented you can now do a lot of things with these tumor slices. And you have shown some longitudinal assessment. So I was wondering how many slices can you cut from each single sample? And you know, how long are they viable for?
Well, obviously, it very much depends on the size of the tumour and how many cores that we can get, actually. In intrahepatic, we generally can cut more than a perihilar mass-forming. Anywhere between 30 and 50, I'd say, routinely. Perhaps a few more. The quality of the slice perhaps reduces with more slices being cut.
And do you see any heterogeneity from the first to the third?
Yeah, we see a lot of heterogeneity across the tumour, hence why we're screening partly to try and remove the stroma.
You try to remove the stroma?
Yeah, well, we have some, but obviously slices that are predominantly stroma, that we generally don't carry those forward into our further experiments.
And do you see that the cell type which form these slices are different from intrahepatic and cholangio and perihilar cholangio? I mean, do you see a different ratio and proportion of cell types within the microenvironment, or is it difficult to characterize?
I can't say that we've seen anything specifically different between them currently, but we haven't looked in detail at the histology at the moment of that. But something certainly we could look at.
I think one of the questions I had when you presented the data about the cell viability is about you check, you know, simply cell viability of the old slice.
Yes.
Do you have any method to see what is the cell viability of cancer cells? I mean, or to eliminate the bias that you look at other cell types that are dying? So
that's where our histology and our immunohistochemistry comes into. So we're trying to train our QPath system now so we're looking at proliferation and cleaved caspase, so more of a marker of obviously have the cells died, more so than whether they're viable, I think, is what we're looking at currently.
And you can differentiate the different cell types?
Yes, certainly, we can do that now. So yeah, we can clearly see the immune cells, the stromal cells. We're using CK19 as our marker for our tumour cells, and we can overlay everything on top now, so we can see those differences. And have you tried to add some other cells on the top of the slices? We haven't currently. I know other groups do that. They've added immune cells, for example, from blood, and we are able to collect blood at the same time as from our patients. So that is something, if we need to, that we can look at in the future. And from a clinical application perspective, you said that you need to process them within 3 hours. Yeah. So do you see that the success changes if you process them longer than that, or is not? In fairness, we've not checked. I mean, the group that I went and trained from, they would collect into organ preservation buffer and then at times would actually process them the following day, but they only ever kept the slices alive for 3 days. We've always tried to do it as quickly as possible, to be honest. Any questions from the audience?
I've got one.
Yeah, please go ahead.
Oh dear.
No, it's not a bad question. Is this on? Yeah. Well, you have to get close.
Yes.
So you said that you can cut multiple slices from the same tumour.
Yeah.
So can you do what people do with PDXs and essentially do a screen with drugs, you know, personalised therapy for patients?
That's our ultimate. That's what we're working towards. I've chatted about this many times with Hassan. In an ultimate world, we'd like to be able to cut multiple slices from across the tumour for each patient and then run a panel of drugs. At the moment, we're just starting with our standard of care chemotherapies, but it totally depends on how many slices I can cut, really.
I mean, obviously, you know, the advantage of having mice is that you can always go back to them and treat them with different drugs, and we don't have that for slices. Do you know if there are new developments this may be a very silly question, for freezing them down and, you know, test them in the future?
That's another string to our bow. We're looking at that, actually. We're doing some modelling with the guys at Surrey, looking at cryopreservation of slices, actually. So that's something, you know, that would be the ultimate, wouldn't it?
Okay.
We've done that in mice.
Your frozen tissue
with pancreas. So made mouse PDXs, if you like.
So you
And freeze them down and essentially sell freeze-down medium and send them across the country, and other people have engrafted them. So if they engraft, they must be able to grow and culture again, or survive.
I was wondering, yes, if you can just freeze the old slice and then, you know.
Well, yeah, we've been freezing
The slice.
fragments, but yeah.
Yeah, because it
Slices.
would be cool if you can then see the functionality of the different cell types so that is maintained. And I mean, going back to your animal models, I think that one of the main beauty to me is that, to my knowledge, this is one of the first model for perihilar cholangiocarcinoma. And we've had a lot of different models of the intrahepatic, and you have probably in all different bile ducts, but with a preponderance to develop extrahepatic. Are you able to differentiate the intrahepatic component from the extrahepatic? I mean, you seem like...
Yeah, for sure.
So they grow separately, or you see just a big mass that is involved in both?
They grow separately.
They grow separately.
Yeah.
Okay, so you are able to analyze really the effect only on one tumor type compared to the other?
Yeah. I mean, in a mouse, the CBD is smaller, so perihilar versus distal, it's quite a small range, but for sure there's a big difference between the intra and extra.
And I think that when you mentioned that there are some changes in the lungs, do you think, or have you observed if those tumors evolve? I mean, does the mouse die of the lung lesion, or is something that we can just disregard?
Yeah, so not in the P10 homozygous. 100% of those mice die of biliary obstruction.
So you see the tumor in the bile grow out.
You just see them there in the lungs post-mortem.
And when you compare with the other model that is SOX derived, and SOX is more kind of a marker of cancer stem cell. So do you see about the changes from the small duct versus the large duct, but do you see if there is a more clonogenic or facility to growth, even if you try to derive the organoids? Do they grow better because they have more cancer stem cell component or not?
Have you tried?
You didn't give me the mice of the SOX. Yeah, no, but it would be nice to probably
we'll send them your way.
SOX to see.
I mean, I know that the CK19s grow
So
as organoids, but
in the animal model, you see that they grow faster or not?
no, the
You don't
SOXs
see
are slower.
Okay. So you're replicating what we see in the human that has small duct phenotype.
Yeah, I know SOX9 is always kind of thought of as a stem cell marker. I've been recently talking to a PDAC dude who's been looking for a ductal stem cell of origin, and all the data seems to just suggest that there is a small population of cells that might be a cell of origin that are CK19 high and SOX9 low. So
Would be
I
interesting.
can't say whether it's the same in the biliary tract, but
Okay, it would be interesting to see. And a question for both of you. We have heard yesterday and this morning that actually the gender can, play quite a big role in cholangio, maybe in, the development of cholangio. Do you see this recapitulating in your model? I mean, do you see them, in your mice or in your slice, any difference?
I mean, in the mice, no, they're pretty rapid. So it might be that we would have to breed more of them to see a subtle difference, but there's not like a massive, obvious difference.
Okay.
For me, at the time of collection, I don't know whether it's male or female when I get a specimen. The surgeons do, and we can probably go back and check.
Are you able to go back and check and, probably see some differences?
Yes, but just sort of from what we've done so far, I don't think we wouldn't have enough to say that there's a definite difference between male and female. And from my viability at the moment, I wouldn't say that there is. But that would just be a limit of n number at this moment. I think you have to get a very large number of patients to see that difference, if there is one.
Yeah, and I mean, when you do through the biopsy, I don't know if you are involved in the collection of tissue from biopsy. Do you need to pose particular attention to the collection of tissue, or
Yeah, absolutely. So I would do have a few slides, but just in case of that question. But for us, obviously, the importance is to try and maintain adequate specimen for the histopathologists to do what they need to do. And the main bit of how I collect the sample, mainly for the perihialis, is to try and not disturb that resection margin that's going back towards the patient. So particularly the liver resection margin and the bile duct remnant, that margin going back to the patient. So I sort of go away from that margin and attack the hilar tumour from the other side to get at the tumour mass. And I think we've had a few questions before about certain tumour types with very much if you're getting just duct sort of sclerosis and fibrosis, that's a lot harder for us to collect, and often there's nothing there for us to be able to get. Whereas if you've got those perihilar tumours that are a bit more mass forming, that's the ones that we can then sample to do those sort of tissue slices on, because ideally what we need is a disc of tissue enough to such that you can core it to get that 5mm core. And I think it's a question earlier that you're saying about in terms of the number of slices that you can generate. Certainly the much larger intrahepatic tumours, you can get much larger tumour disc out, you can generate multiple cores, you can maybe get up to 30 or 40 slices per core. Not all of them, you want to take the best ones, not all are perfect, and that lowers slightly with the perihilar ones. And just a comment, so I think you asked it earlier in terms of how do we know about the viability in terms of the different cellular populations. So obviously MTS, it's a very raw test, it just shows overall slice viability, and that can be contributed from the tumour cells, from the immune cells, all different cellular populations within that. So when we do, at each of those time points, we're taking those slices, putting them into FFPE blocks for histology. We could cleave caspase both across the slice, but then using QPath with our histology colleagues, we can identify the different cellular populations within that, so we know what proportion of our tumour cells are alive or dead at each of those time points. And what we can see at the moment, although we're increasing our numbers all the time, is that we are sort of maintaining tumour cell viability sort of across that time period, which is obviously important for us. We want to make sure that those are above all what we're keeping alive in culture for our drug testing.
And I mean, have you tried to collect the normal tissue to see the toxicity of the drug?
Yeah, absolutely. So the beauty is we can get matched normal liver as well. So going forward, you could see examples whereby you could try and optimize, treatment response versus toxicity within the liver for certain chemotherapy compounds, and that's something that we've not done yet, but that's something we're looking to use this platform to look at. Within cholangio, particularly colorectal liver met, other tumour types.
Yes. Yeah. Interesting, thank you. And Jenna, do you see a periductal growth in your mouse, in the perihilar, or do you see more a mass forming? A periductal growth, do you see if the tumour grows as a big mass, or there is a lot of stroma and they tend to grow within the bile ducts?
A bit of both, yeah. So the whole bile duct essentially becomes affected as the tumour grows. You can see it really nicely on ultrasound. Actually, the whole thing thickens and then gets occluded.
Okay.
And the mouse turns yellow.
We have a question?
Yeah, so just a quick question. It was both really good talks and really interesting about the precision cut tissues. So this is a bit of a naive question on my part maybe, but you obviously can show that they're viable and you can keep them in culture. Have you seen whether, or maybe it's not enough time that they're cultured for, do you see growth of any of the cell types within these tumours or these sections, or have you tried putting those sections in like Ultramatrix or Matrigel and seeing whether they establish 3D shapes, or is it not long enough to be able to do that?
We haven't done that yet. We've done some very, very preliminary experiments where we're actually able to put the slice onto a more biological membrane, and we do get vascularization of that, and there is some suggestion potentially that it will start to proliferate, and then would enable us to sample that again. But we haven't tried put it into Matrigel, so we simply put them onto like inserts, tissue inserts, and leave them at the aliquid interface at the moment. I'd need to go back and look at histology, but as I said, there is evidence that there's some type of wound healing around the edges. But
okay, and so you find the vasculature regenerate and regrow, but do the biliary cells themselves regenerate and grow, or you're not sure?
I'm not sure at the moment.
Okay, cool, thank you.
Thank you very much. If there are no other questions, we will close the session now. Thank you, Jane, and thank you, Laura. And we are now inviting, Lorenza and Ellen to give the closing remarks.